We've reached the end of another skill, and that means it's quiz time. First up, out of 5 questions, what are the 2 components that, when combined, form the solution Cisco calls software-defined access? Well, this is going to feel a little bit like a math operation. When we take Cisco TrustSec and combine it with VXLAN, and combine that with Lisp at the control plane, well, this solution right here is the Campus Fabric, which is one of our answers. Campus Fabric on its own is a validated design by Cisco. However, when we combine DNA Center with Campus Fabric, this is what equals SDA. Next up, what are the 4 layers of SD access? Well, just like with the OSI model, we start with the physical layer. Physical layer, this is where all of our hardware lives because, again, we have to build a software-defined network on actual hardware. Next, we have the network layer. The network layer consists of both the underlay and the overlay. After that, it's the controller layer. This is where our actual controllers live. And remember, there are 2 that we care about. We care about DNA Center, or DNAC, and ICE. And last but not least is the management layer. The management layer is how we manage this environment. So this includes things like the GUI access. It also includes REST APIs. And then within the management layer, Cisco has the 4-step workflow that we use to manage the SDA environment. Question 3. If the platform is capable, what 2 roles can be shared on a single device? Well, the answer here is B and C, Fabric Border Node and Control Plane Node. A Fabric Edge node is focused on user connectivity, and guess what? So is the Fabric Wireless LAN controller. It just happens to be that the Fabric Edge node is for wired users, and the WLC is for wireless. Now that said, even though we can combine these 2 roles, and that fits in smaller environments, in large environments or environments where roaming is heavy, we do not want to combine these. We want a dedicated control plane node so we don't bog down the system. Because if an edge node can't figure out where anybody is because the control plane node is too busy to respond, well, that's going to grind our network to a halt. Question number 4. How many bytes must be accounted for when configuring an underlay for VXLAN transport? Well, either you know it or you don't, and the answer here is 50 bytes. So we need to increase the MTU on all of our underlay devices by 50. Last question. Which DNA Center subsystem was formerly known as APIC EM? The answer here is the Network Control Platform, or NCP. This is responsible for automation, which is exactly what APIC EM was designed to do. As Cisco's vision for software-defined access expanded, APIC EM became just one component of the overall solution. Incidentally, by the way, the only other subsystem that DNA Center has is the Network Data Platform, or NDP, and this is responsible for assurance. Well, that wraps up this quiz. If you found yourself with any knowledge gaps, then be sure to go back and watch the appropriate videos in order to fill them. Otherwise, congratulations on completing Explain the Principles of Software-Defined Access. I hope this has been informative for you, and I'd like to thank you for viewing.